In this video, we're going to be taking a look at economic lot size. And this is an interesting concept because a lot of times when we think about minimizing production costs, we literally just think about the costs of producing said object. But for a lot of things, the demand won't necessarily be sufficient that you will be immediately shipping out all of the things that you're producing. You're going to have to store them first in a warehouse. And a lot of times, those warehouses will have a rather high cost for storage. And so, if you truly want to minimize setup costs, we if you think about it, on the one hand, if the company manufactures the item only one time a year, it would minimize setup costs, but then it would incur high warehouse costs, right? Because then you would have to store that huge batch for use throughout the whole year. On the other hand, if you make a bunch of small batches, that increases the setup costs on the front end, even though it might minimize the storage costs. So, what we want is we want to use calculus to find the number of batches per year that we need to make in order to minimize total cost. So, setup and production cost and storage cost. And the formula that does this is called either economic lot size, which is what our book calls it, but sometimes you'll also see it referred to as economic order quantity. And those are just two different ways of referring to the same thing. Now, if you want a proof of where this formula comes from, you are welcome to take a look at it in the text. It's in there. I'm actually not going to go through the proof. I think y'all probably trust me that this is actually the formula that does what it's supposed to do. And so I'm just going to show you what the formula is, and then we'll do an example of how to set it up and use it. So the formula itself says x equals square root of km over 2a. And so we might then well wonder, what are these quantities? So x here represents the number of batches to be manufactured annually. Because again, making only one batch a year minimizes setup cost, but maximizes storage cost. So we want to make smaller batches throughout the year, but we want to know how many smaller batches should we make to minimize total production and storage cost. So that's actually what the X here is, and that's what we're going to be solving for. The things that we're going to put into this formula, the A here is the fixed setup cost to manufacture, there we go. Fixed setup costs to manufacture the product. So what are your fixed setup costs? The M here is the total number of units produced annually. And that will, obviously depend based on the type of thing that you're producing, what type of units you're measuring that in and how many of those you're producing. And then K here, the lowercase k, represents the cost of storing 1 unit of the product for 1 year. Storage cost for 1 unit for 1 year. Okay, so that is our formula for determining this optimal number of batches to make. And those are the quantities we need to know. What is our fixed setup cost? How many units are we making a year? And what is the storage cost per unit for 1 year? Okay. So let's take an example. Here's one where we have, let's see, where to go. Okay. So we have a large hospital has an annual demand for 50,000 booklets on healthy eating. So 50,000 booklets annually. So that's their demand. Then it costs 75 cents to store one booklet for a year. 75 cents to store one booklet for 1 year. Let's see, and it costs $80 to place an order for a new batch of booklets. And we want to find the optimum number of copies per order. Again, the assumption that we're making here for economic lot size to work as a concept is that the optimum number of copies per order is the number of copies per order that produces the lowest total cost, right? So if we go back to that formula, X is the thing that we're solving for, right? The number of batches to be manufactured annually, okay? Then we have into our equation, we have a square root. Then the first number that we put in is the lowercase k. And the lowercase k represents the cost of storing 1 unit of the product for 1 year. So one booklet storage cost is 0.75. Then, under the square root, the next thing that we're putting in is capital M, total number of units produced annually. So we're making 50,000 booklets in a year. In the denominator, we have the number 2. And then lowercase letter a, fixed setup cost to manufacture the product. So the fixed setup cost is 80. Okay. So that's all we're plugging in. Now, the one thing that tends to trip people up here is how you put this into your calculator really, really matters, because the very last thing that we're doing is taking the square root. So if you're putting this into your calculator all at once as one single expression, you're actually going to have to use a ton of parentheses. And if they don't end up in the right place, you're going to end up with completely the wrong value. I think the easier way to do it is to find the numerator quantity and the denominator quantity, divide those two things, and then take the square root at the end. Okay, so if we were to do that here, if we find our numerator quantity, we're looking at 0.75 times 50,000. And so we'll just plug that right into the calculator, 0.75 times 50,000, and we get 37,500. So that's just the numerator. The denominator, 2 times 80, that's 160. And then we're going to take the square root of that. Okay. So if I take 37500, 37,500, divide it by 160, I get 234.375. And then that's the thing that I want to square root. And it's looking like about, whoops, we have about 15 batches. We're rounding this to the nearest whole number value. Okay. So that is the number of batches per year that's going to minimize the total cost of both production and storage.